we need to test for the uniform convergence of the series infinite sum on x divided by n plus x squared the power 2, right? So in this case also we are going to use the WEIERSTRASS M-TEST. In the previous example we have also used D'Alembert's test, D'Alembert's principle. But when we can use the D'Alembert's principle if the given series is of the kind a n x the power n. In such kind of series we use a D'Alembert's test for the series to be convergent, right? And then we apply the WEIERSTRASS M-TEST for the uniform convergence. Alright. But here the series is of the different kind, and also one important thing is here interval is also not given to us. So what we need to do is we just get the maximum value of this function and prove that this maximum value is convergent. If the maximum value is convergent, then the mod of this itself is convergent. And then we apply the WEIERSTRASS M-TEST to prove the series to be uniformly convergent, right? Okay, let's start with the solution. So this is the given series and let's get the maximum value for this function. So let's take u and x to be x divided by n plus x squared the power 2, and then we need to find the derivative of this function, that is u n dash x, the first derivative. So this is n plus x squared the power 4, then is the denominator into the derivative of the numerator minus numerator into the derivative of the denominator into 2x. And then this is, let's take n plus x squared outside, and we are having n plus x squared minus 4x squared divided by n plus x squared the power 4, and this cancelled out and we are getting the power as 3. So this is equal to, this is n minus 3x squared divided by n plus x squared the power 3. Please mark this as 1. For maximum or minimum value, we need to put u n dash x to be equal to 0. This implies this n minus 3x squared divided by n plus x squared the power 3 is equal to 0. That implies n minus 3x squared is equal to 0. That is, n is equal to 3x squared, and we are getting x to be equal to plus minus square root of n divided by 3. Let's look out for the sign. Let this point be the square root of n divided by 3 and this point be negative of square root of n divided by 3. Let's check about the signs. How u n dash x changes sign at what point, right? So for that, let me take the values of x less than square root of n by 3. Take x1 to be equal to square root of n divided by 4, which is less than square root of n by 3. Let's check the value of u n dash x at this point. So for x equal to square root of n divided by 4, what is u n dash x? It is n minus 3x squared divided by n plus x squared the power 3. So at x equal to square root of n divided by 4, what we are getting? N minus 3n by 4 divided by n plus n by 4 whole cube. And we are getting this 4n minus 3n to be n divided by 4 divided by the denominator. So we are getting the positive sign, right? So for the values which are strictly less than square root of n by 3, we are getting positive sign. Let's consider the values greater than square root of n by 3. x2 to be equal to square root of n divided by, let's say, 2. So for x2 equal to square root of n divided by 2, what value we are getting at u n dash x? So at x equal to square root of n divided by 2, this is n minus 3n divided by 2, and in the denominator n plus n divided by 2 whole cube, And then we are getting this to be as a negative n divided by 2, and in the denominator n plus n divided by 2 to the power 3. That means we are getting a negative sign, right? Here n is positive because n is starting with 1 to infinity. So numerator is positive, denominator is also positive. But we are getting negative sign with the numerator, right? So that means for the values which are greater than square root of n by 3, we are getting negative sign. So what does this mean? This means that un dash x is changing sign from positive to negative at x equal to square root of n by 3. That means un dash x has maximum at x equal to square root of n by 3, right? And when we put this value at unx, we are getting the maximum value of unx. Fine? Okay. So this implies un dash x changes sign from positive to negative at x equal to square root of n by 3. This implies unx has maximum value at x equal to square root of n by 3, right? And let's find the maximum value. What is unx? It is x divided by n plus x square whole square, right? So at x equal to square root of n by 3, we are getting the maximum value of unx. So putting this value, we get square root of n by 3 divided by n plus n by 3 whole square. That is equal to square root of n by 3 divided by 4n whole square into 9. So that is equal to 9 into square root of n by 3 divided by 16n square, which is equal to 3 root 3 divided by 16 into 1 divided by n the power 3 by 2. Please simplify this. So this implies unx is less than equal to its maximum value, right? That is 3 root 3 divided by 16 into 1 divided by n the power 3 by 2. Which further implies that mod of unx is also less than equal to 3 root 3 divided by 16 into 1 divided by n the power 3 by 2. What is unx? Just writing that. It is x divided by n plus x square whole square less than equal to 3 root 3 divided by 16 into 1 divided by n the power 3 by 2. Now let's take summation on both the sides. So the infinite sum where n starting from 1 to infinity on mod of x divided by n plus x square the whole square is less than equal to summation n going from 1 to infinity 3 root 3 divided by 16 into 1 divided by n the power 3 by 2. We can take this outside of the summation because there is no n. Now let's check, is this power is strictly less than 1 or greater than 1? Yes, 3 by 2 is greater than 1. And because the power is greater than 1, this series is convergent. But summation n going from 1 to infinity 1 divided by n the power 3 by 2 is convergent. So therefore, by Weierstrass M-TEST, the given series is uniformly convergent. So it converges uniformly for all x. Thank you.